Thank you very much and welcome. Dr. Lilian Alessa received her PhD in cell biology from the University of British Columbia. She also has had extensive training in human psychology. The combination of these two disciplines has led her to study system science and complexity. Lil grew up on the Burrard Indian Reservation, and these roots have strongly shaped her work. Currently, in 2001, she joined the faculty at University of Alaska in Anchorage as an assistant professor, and then in 2005, she was promoted to associate professor. She currently leads the Resilience and Adaptive Management group at UAA and is affiliate faculty with the Water and Environmental Research Center here in the Institute of Northern Engineering at UAF. She has been lead scientist on several projects dealing with human adaptation to change, including the establishment of a National Center in Complexity Modeling for Social Sciences in collaboration with the University of Arizona, Arizona State, and the Santa Fe Institute. I've personally had the pleasure of working with Lil on several projects over the past 5 years. Her enthusiasm, creativity, and what I just call her big thinking has really inspired me and many others. So it is therefore with great pleasure that I introduce Dr. Lilian Alessa.
Okay, thank you very much for coming tonight, and I have to say in exchange that I couldn't ask for a better colleague than Dan and the group at INE. Okay, what I have to talk about tonight is going to take a slightly different angle, perhaps, than you're used to hearing. What I'd like you to do is maintain an open mind and bear with me. I am Canadian. Are there any other Canadians in the audience? All right. Okay, I was really disappointed that the Canucks were not playing in the Super Bowl, but oh well. As Dan mentioned, I grew up on the Burrard Indian Reservation. I was in St. Edmunds Parish, St. Edmunds School, and one of the things that frustrated me growing up was when scientists would come to the community and they would offer suggestions on how to change. And it was very confusing for people in the community. And it continues on in the scientific community today. And what we're trying to do, and this includes some colleagues, Dan and Andy and a few other folks who are here, is really try and bridge that gap between science and on-the-ground application. Let me read you something out of the literature. It is an anatomy of adaptation to climate change. Climatic stimuli include changes in long-term mean conditions and variability about means, both current and future, and including extremes, period. Adaptation depends fundamentally on the characteristics of the system of interest, including its sensitivities, vulnerabilities, and ability to adapt. These are just some folks of some of my family. So let's walk through what we're going to talk about. This is a very, very big topic, and it was a real challenge to put it together tonight. We're going to talk about climate change, and we're going to talk about the feedbacks of climate change. If you look in the American Heritage Dictionary on the usage committee, there is a usage problem with the word impacts. Impacts means to pack tightly in a small place. It is a pretentious word. It is jargon. So I want you guys to start thinking about feedbacks rather than impacts. We're going to talk about water resources because water is life. Water is essential to everything on Earth. Then we're going to talk about adapting to change. And again, I put global change because climate change is one aspect of many changes occurring simultaneously on the planet. And then I would like to introduce to you what we have been working on with the Water and Environmental Research Center and collaborators around the world. This is the synthesis of many years of work, is the Arctic Water Resources Vulnerability Index, or ARVI, as it's affectionately known. Climate change is oversimplification. Now, human outputs are real. Climate change is real. We have modified, depending on which estimates you look at, up to 60% of the Earth's surface. However, climate change per se, rather than a venue of objective science, has become an economy of fear. We start to see words associated with climate change like dire and doom. There are many uncertainties regarding the outcomes and feedbacks in this context. Not that things are changing. We have no doubt that things are changing. But when we talk about change, we always talk about greenhouse gas emissions, GHGs. Now, how many of you guys have heard of greenhouse gas emissions? Okay? Okay, good. How many of you guys have heard about CDCs, or core drivers of change? Okay, a few people have. How many of you guys have heard of Hippo? Not Hippo, but the acronym. Anybody? Hippo. Okay, we'll talk about Hippo in a minute. Let's just start from the basics and looking around the room. I know there's some of you that have extensive backgrounds what climate change is. So basically, the Earth has an atmosphere, and the atmosphere traps heat coming from the sun. Now, you can trap more heat or less heat. Some of the heat is absorbed by Earth processes. The type of surface that sunlight hits affects how much is absorbed and how much is re-radiated, bounced back into the atmosphere. Now in the Arctic, we have a slightly thinner atmosphere, so things warm up a little more quickly. Now there are also components of the way the Earth distributes heat around the planet, from the equator to the poles, the differences between the temperature at the poles and the equators. But in the Arctic, more of the extra trapped energy goes directly into warming rather than into evaporation. So the Arctic is a place where we expect to see exacerbations or increases in variability in warming. Now, in addition to the fact that atmosphere traps heat, okay, it lets some stay in, lets some go out, that creates the ability to have life on Earth. There are also these larger cosmic cycles. They're really, really cool. Milankovitch cycles, Dansgaard-Oeschger cycles, Heinrich events. These are basically how much the Earth is tilted, what the shape of the orbit is, how much solar energy is coming in by virtue of how much output the sun actually has and where the Earth is intercepting that energy. Now, Dansgaard-Oeschger events are rapid warming events, and it suggests that there are large-scale complexities as well. There will be a test on these graphs, so please pay attention. All I want you to get here is variability. Okay, I'm going to give you some words to take home. Okay, the first word is going to be variability. 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 Things are very variable. Okay, they go up, they go down. This is from a science article by a colleague of many of us in this room, Jim Overland, showing how we may expect variability to occur in the Arctic. So we see, we see the temperature changing significantly. So we're starting to talk about not so much planning for warming as much as we're talking about planning for variability. And this variability is inherent in the Earth system. It's inherent in the way the Earth is constructed. depending on, remember we're talking about the difference of temperature at the poles to the equators, depending on which latitude you're at, those energy balances are different, the variability is different, but it is there. Okay, this is a variable system going back many hundreds of thousands of years in many different kinds of records, and going back not that far. So we talk about a lot of how society is structured by those variabilities, variations in climate. Norway went from a wine-producing, a grape-growing area to a place depauperated by cold, okay? Poverty, starvation, Scotland, the origin of many kinds of beers, okay? To many people's delights. So variability is the word I want you to take home. This is a variable system. What we're expecting to see is an increase in variability. The next word I want you to take home is feedbacks. Okay, so this is a variable system. Earth positioned in the cosmos. Lots of variation in there. Now I want you to take the word feedbacks. Every process that occurs has an effect that feeds back or is integral or inherent or part of another process that is occurring simultaneously. Now, feedbacks can be positive or kind of ramp the system up, or they can be negative and kind of ramp it down. In terms of warming, there are some factors that can increase or rapidly accelerate warming. For example, methane pockets releasing pulses of CO2 into the atmosphere. And there are things that can mitigate that and actually cool the Earth. This is a complex system, and we're doing a whole course on complexity. We're doing a whole class on what complex systems are. So I wish I had time to get into that because it's really, really cool. But two things that I want you to take from this are two words: emergence and hysteresis, for use in daily conversation. Okay? Emergence, patterns that basically cannot be predicted based on the available data. Okay? And we can talk about this afterward. We're actually creating some really cool new tools to try and detect emergence. And then hysteresis is basically the lag, the delay in seeing the effects from the interactions of different variables. Okay, so we always hear about the positive effects. Well, some of the cooling factors on the planet are also those which are not necessarily good for the functioning of ecosystems, or don't maintain the functions of ecosystems very well. For example, China is burning enormous amounts of coal, low-grade coal. This produces a lot of black carbon. It's a particle emitted into the atmosphere. And at any time, particularly because of the way humans have altered landscapes and transformed matter, okay? Transform matter from one thing to another. We'll talk about that in a minute. There are a lot of aerosols in the atmosphere. The Asian brown cloud, how many of you guys heard about that about 4 years ago? Okay, so a few people have heard of that. Actually caused regional cooling. It was so dense, it reflected sunlight pretty well. Okay, now, here's where I want you to open your mind and bear with me. This is a UN Environment Program graphic, and it goes like this. Potential climate changes impact, so here we have the sea level rise, temperature, changes in the water cycle, precipitation. You guys, a lot of you guys have heard about this. And this impacts on health, agriculture, forests, water resources, coastal areas, species, and natural areas. Yes, it's completely backward. Why? Why is it backward? Let's talk about this. Let's get to the root of this. Okay, this is going to be hard to read. Let's walk through it. We have land use changes, urbanization, deforestation. First law of thermodynamics, going way back. Matter cannot be created or destroyed. Thank you. Okay, it can only be transformed. Okay, so we transform matter really well, and we need something to help drive that transformation, to run the engines. And that is, matter transformations are fine. Matter always transforms. In the process of doing this, we produce these greenhouse gas emissions. These, of course, affect the carbon cycle, very important cycle. And we have the greenhouse effect, remember that atmosphere, which causes a whole range of effects, the average temperature rise, ocean circulation changes, and then goes down into what is objectively called disasters. And we see casualties, famines, loss of biodiversity, economic losses. It goes on and on. We're missing a link here. It's a very important link, and I think we're missing it not only in the public arena, but we're missing it as a scientific community. And these are fairly slow processes. Okay? They're relatively slow processes compared to what happens when you change three-dimensional structure of a landscape, for example, in 2 days. How many of you guys get National Geographic magazine? Okay? Awesome, good. How many of you guys, do you remember the issue before last? The last issue was Healing the Heart. What's the issue before that? On the cover was a lone tree in the Amazon basin. Deforestation in the Amazon. At current rates of use, during the 90s, we saw kind of a slowdown in harvesting in the Amazon, mainly because of public outcry, views in the Amazon. And then we saw that creep up, creep up, creep up, creep up. At the current rate of use, we expect 60% of the Amazon basin to be either completely deforested or rendered non-functional in 20 years. That's very quick, very rapid. So let's look at the big picture here. We have human consumption. I just put in a few of these. And the key here, that we're going to get into a bit more, and the one thing that I have really taken from the research that I've been doing, kind of hit me in the face like a ton of bricks, is that the smallest things add up. My cup. Okay? This counts. So, human consumption, I put just a few things in here. This results in, okay, one of the feedbacks is land use and deforestation. In the process of doing this, we emit greenhouse gases, pollutants, and aerosols. The two of these occur simultaneously and interact with each other, and we have a scale effect. So they interact with each other at different scales. Sometimes it can be incredibly rapid. In the case of the Marashon Indians in the Amazon, one part of the Amazon basin, it was 2 days. Okay, so some of these can be very quick, but they result in emergent patterns. So really looking at climate change as a component of this complex system is what I'm trying to get you guys to reframe your thinking. Let's get back to Hippo. It's pretty simple. Everything is connected. Everything is related really to this overconsumption. And this is down here so that the acronym fits. But basically it's the question of what constitutes a sustainable lifestyle. If we look at the big four, we have habitat loss, invasive species, pollution, and population growth. We now cover the surface of the earth as a species. This is unprecedented as far as we know in history. And so Hippo, driven by overconsumption, is resulting in the sixth extinction. How many of you have heard of the sixth extinction? Okay, so a few people have. What it is it is a mass extinction that is the fastest, as far as we can tell, in our planet's 4.5 million year history. And for the first time, it is another species that is driving the extinction. So it is an enormously popular issue among scientists, but it's one that has really taken the sideline in light of climate change, which again is simply a component of these drivers, these core drivers of change. And loss of biodiversity, loss of habitat, really is a function question, a question of ecosystem function. And it really is a human condition as well. There are many tens of thousands of people who are losing their lives and livelihoods as I stand here because of habitat loss. Okay, so we're talking about altering habitats very rapidly. Okay, land use transformation. And we're talking about, now I want you to think about this again, going back to the big picture. We have these land use changes, ecosystem changes. In the process, we produce the greenhouse gases. So we have the core drivers of change here, greenhouse gases here. These are combining in these landscape changes, climate changes, and they're interacting with each other. Well, they're affecting a lot of systems. One of the systems they affect very quickly, and one of the most core systems to life on Earth, is the water cycle. So water resources. The water cycle, wonderful, amazing cycle, has resulted in my water here under the podium. Basically, simplifying it here, water evaporates from the oceans, moves around, condenses, falls on land, goes into different compartments, including us, okay? Is captured, is dammed up, used for irrigation. Some of it goes down into the water, is pulled out in wells. Everything flows down to the ocean. Some of it falls as ice and snow. This has resulted in the formation of glaciers worldwide. So you can see that everything revolves around water. Okay, so I mentioned ice and snow. Globally, there have been changes in sources of water. And we're going to start with something like glaciers. Around the world, glaciers have been changing significantly, and primarily they have been retreating. There are some that are actually advancing, but in general we see a trend toward glaciers thinning and retreat. This is occurring down in South America, a very key and core issue right now in South America. A lot of the communities, for example in Peru, in the Andes, rely on glacial runoff because of low summer precipitation. The Himalayas, also, we're seeing changes again. These are very arid, dry areas that rely on this storage and replenishment of glaciers. So globally, we are seeing water issues popping up because of the loss of these glaciers. This is really interesting. This is Dan and Andy and Bob, if you're here, and I work with folks in Iowa who work on precipitation. And this is kind of a general pattern. We're going to see precipitation patterns change. Some areas are going to see more precipitation, some areas are going to see less precipitation. The areas that we believe are going to see less precipitation are those who can least afford it. For example, sub-Saharan Africa. These are areas that are already limited. We already see loss of life because of water poverty issues. And what we're expecting in the northern hemisphere is basically it to become a little bit wetter, so more water in the northern hemisphere. Again, take this with a grain of salt. This has been completely revised for Australia so that they're more on the water poor area. Of course, with changes in precipitation, we have changes in runoff, changes in flooding status, and we have this concurrent climate effect of the oceans absorbing heat and primarily expanding. Okay, so we have sea level rise, we have these water running off the land, sea level rise, and we basically see these risks to coastal communities. Now, don't underestimate how far inland ocean can go, even if it rises just a little bit, half a meter, so it's not all that much. Now, how many of you guys have heard of Bangladesh? Okay, okay, great. How about Jakarta? Okay, what's happening right now in Jakarta? About 3/4 of it are flooded out. How many of you guys have heard of Banjul in Gambia? Okay, a few people have. It's a mega city that has just built a dual carriageway, roadway. And this roadway is expected to last about 5 years. So this, again, is a global problem. Talking about places in Kiribati, small island states, basically who have no options. They are simply have to relocate to Australia, New Zealand, the Nile Delta, Bangladesh, a lot of the world's poor areas. Okay. A note here, I have a really cool graphic, but I have so many graphics that I don't want to overwhelm you. One of the other consequences from the Arctic to Europe is this increased fresh water entering the North Atlantic current. If we have time at the end, I'll show you this movie. But that has the potential to change the speed and the magnitude of the North Atlantic current and ultimately affect climate in Europe. And we're talking about a cooling in Europe. Of course, the implications of this you can probably imagine. Okay, so Alaska and the Arctic are facing changes, just like the rest of the world are. They have some unique features. The main two features are sea ice, the polar ice cap, and of course permafrost. Now, changes in permafrost have enormous implications. Sorry, changes in sea ice have enormous implications for coastal erosion. Sea ice acting as a buffer for storms. A storm comes in, if there's less sea ice or open water, of course, those shorelines are prone to erosion, underlain by permafrost. And that without sea ice, you have increased rates of coastal erosion. Many of our communities are located on the coast, and so we have to deal with that challenge. Roads and structures, as permafrost melts, sink into the ground. In Russia, they quite often lay down these massive floating roadways, very expensive, very labor intensive to move just a few miles on thawed permafrost. You guys probably see it up here, buckling of roads, infrastructure, structures, the pipeline. So lots of challenges with respect to just man-made structures on a changing substrate. Of course, shifts in vegetation. We're starting to see what we call a greening Arctic. We're starting to see tree lines change. We're starting to see shrubs move northward. Of course, this has enormous implications, sea ice, permafrost, and vegetation shifts for subsistence species. And something that's maybe underrated, but if you have tried to dry salmon in the rain, you will appreciate that conditions necessary for preserving food are also changing. And this has profound implications for communities that rely on this. Okay, so let's talk about water in the Arctic. We're going to see changes. Permafrost is going to be variable. Okay, it depends on the type. If it's continuous, if it's discontinuous, where it's located, is it north-facing? With sea ice, we are expecting thinning. We're already seeing thinning. We're expecting thinning during late summer. With precipitation, this is going to be highly variable. It really depends where you are. In general, precipitation increases. And with soils, of course, we are changing the way the roots of plants exist in soils, whether or not ice is there, what kind of microbial communities are there, how nutrients are turned over and are able to be taken up by plants, water balances in those soils, how much they can hold. You guys are starting to appreciate the connectivity, yeah? The connectivity and the complexity of the system. So what are we talking about for the Arctic? Well, generally, a warmer, wetter, greener Arctic with sparse sea ice conditions favoring the northward expansion of southern species. Okay, we're starting to see beavers move north. We're starting to see beavers move into salmon streams, okay, changing a lot of the dynamics there. We are going to talk about rivers as a special case because the work we do really looks at rivers and stream networks. Now, anybody got any tomatoes? Okay, opportunities in a warmer, wetter Arctic. What happened in 1941 for the Northern Sea Route? There was a warming episode. It coincided with a kind of global event, World War II. But there was a warming episode during the 40s. And anybody know what happened in 41 in the Northern Sea Route? It was ice-free, so shipping proceeded. We have shipping across the Arctic. We just require nuclear or fuel-intensive icebreakers to move these ships around. We already have shipping there. And what a thinning polar ice cap would do is basically facilitate the northern shipping route. Now, remember, we're not going from no shipping to shipping. We're going from some shipping to more shipping. Whole set of implications for that. It may actually save petrol. fuel, okay, because of reducing the amount of fuel required to make longer trips through the canal. A lot of effort is actually going toward looking at agriculture. We know that northern regions were once agricultural areas, crop-producing areas, and so we're looking at these areas becoming crop-producing areas again. What crops can we grow further north? And we're looking as sea ice retreats and as ocean dynamics change, ocean regimes change, atmospheric forcing of various currents. We're looking at a change in the range of fish species and how accessible those fish species are. This is as much an exercise in wisdom as it is an opportunity. And I have a lot of information on this, many slides if any of you are interested afterward. Okay, so we know things are changing. Lots of changes. Pick your changes. Well, what are we going to do? Well, we talk about adaptation. It's basically the general ability to adjust to change, to minimize the consequences, and to capitalize on the opportunities. And this is from the Millennium Ecosystem Assessment, not the Matanuska Energy Authority. One of the key components of adaptation is really accepting the trade-offs. It's really recognizing that one of the trade-offs of adapting may not be life as we know it. Adaptation simply will not happen as once. We talk about adaptation as this process that we're going to undertake, that we're going to plan and execute. Adaptation is one of these things that happens really by opportunity, by locale, by community. And one of the suggestions for adaptation, one of the prescriptions, is to diversify your options. What we need to do as a scientific community is step up to the plate and recognize that a diversity of options includes natural resource development. Okay, nobody threw anything. Without recognizing this, as a scientific community, what we're doing is we're basically putting to the side one of the realities of our existence. All right, boy, we could do a whole class in adaptive capacity, and one of my other colleagues and somebody I really look up to is right there, Terry Chapin. He's done a lot of work in this. So adaptive capacity, I could go through all these lists of what it is. I just put up a few. It's learning, how much technology you have, do you have the means to adapt, how exposed are you to the risks, and we can go on and on and on. Now, adaptation can be reactive or proactive. You can survive or thrive. My father was an orphan. He was found kind of half alive, and he's gone through his life thriving. And he's one of these people who I look at as an example of adaptation. If you view change as a loss, well, you might survive it. If you view change as an opportunity, more likely you'll thrive. And the one thing I love about this graphic, this is an old graphic, is that this really reflects that adaptation to change is not a uniform process. Now, we looked at some of the things that are happening around the world. If you've traveled around the world, if you've gone to some of these areas, if you have seen what is happening, what has been happening for a long time, really ramped up in the past decade. I think we're really lucky living in Alaska. I think Alaska is very resilient to change. And I think there are a number of reasons for this. This is a place with a history of adaptation. My goodness, Arctic peoples live in one of the most challenging environments on the planet. I live in a couple of worlds. On the planet, and they have thrived in it. So there's a history of adaptation. The Bering Land Bridge was emerged and submerged about 12 times in the last 100,000 years. The Arctic was warmer, colder, and people responded to these changes. We have an abundance of natural resources, whether we are talking about the traditional standard tangible oil and gas and mineral resources, whether we are talking about the natural aesthetic beauty that drives tourism, Alaska really won the lottery in that. Lots of the rest of the world becoming very crowded. The value of wilderness areas as a destination is really growing. We have the anticipation of thawing permafrost. We have engineers who are focusing their entire careers on how to mitigate, how to build, how to prevent losses from permafrost. We anticipate these changes. We still have access to subsistence species and the means, the technology, the foresight to respond to the changes in their distribution and abundance. If you travel to some places and visit some of the local communities there, their subsistence species are not just moved. They've not just moved. They are gone. We also have the luxury of information. Okay, data is wealth. Data are wealth. We have millions of dollars spent annually by governments, by the government, by National Science Foundation, really to understand our system. This is really a jackpot. A lot of other nations simply don't have this luxury. They can't put the money toward researching or trying to understand their environments. They are too busy reacting to the changes that are occurring around them. We also participate in a global economy. It's not as if we're completely isolated from global economies. Resources and goods, oil, gas moves to all parts of Alaska. We can fly planes into the bush. We participate in a global economy. So it's not a massive change to basically diversify that participation. So we talk about, adaptive management. But really what it is being able to respond to walking out the door and it being, whatever it is, minus 200 or 20 degree or 80 degrees Fahrenheit the next day. So it's really the rapid response, being able to say, okay, if it's 20 degrees the next day, yesterday it was minus 11, okay, we've got something to deal with that. Another core that I mentioned was accepting the trade-offs, recognizing that life may not be as we know it. Okay, so we talk about diversifying options. Well, a really strong theme in a lot of the adaptive capacity, adaptation literature, is diversify. Diversify. The more options you have, the better. Well, let's talk about water in this. And here's where we're going to start to consider rivers. Okay? Resource development is inevitable. Whatever that resource development may be, it is inevitable. Now, the Arctic is not pristine. We consider it relatively unmodified compared to the rest of the world. And the Arctic, of all places, really has water as a core and unifying component. Now, remember I gave you variability and feedbacks. Okay? I want you to add to that small things add up. They really add up. And I'm going to show you a couple of graphics. First, let's look at the Circumpolar Vortex. This is a really cool system. Now, it consists of the air and the water and the oceans. Okay, let's start with the air. I'll run this a couple of times. Okay, so here we are looking down on the Arctic. Okay, we've got Norway and Greenland, and let's see how our air circulates. The circumpolar vortex is really a dynamic of the atmosphere that keeps emissions into the atmosphere over the Arctic. What is produced in the Arctic stays in the Arctic. Okay, originally carbon emissions in the Arctic were thought to have come from North America. We now know that they primarily come from Russia and from within the Arctic. So the Arctic is the generator of its own emissions. Flying in today, it was a clear day, and the Arctic haze was really pronounced. It was very pronounced. Okay, so if we run through that again, I want you to really pay attention to this contained system here. Okay? keeps it over the Arctic. Dips down a little bit, maybe picks up some coal from China. Okay? This is significant because what's carried in the atmosphere can be deposited onto the land and into the water. An example of that is mercury from coal burning. Okay, the troposphere, by the way, is where we live. Okay, so what happens in the Arctic stays in the Arctic. So, cumulative effects. Here's our vortex. We have our transportation by air, and I want you guys to focus on this river discharge. The Arctic is really cool. It's a big basin into which a lot of things flow. Rivers flow. All these watersheds drain into the Arctic Ocean. If we look at development in the Arctic, and this is a really old map, okay, and this is just the areas that are big and have been reported. And if you fly over Kola Peninsula in Russia, it is absolutely mind-boggling. The smelters, the plants, the depots. I have not included military sites, including BUDS, formerly used defense sites. Okay, lots of military sites along the coastlines here. Doesn't include ports. So there is a lot of development in the Arctic, and you really see this when you fly across it. If we zoom in, we see that there are some really extensive developments, and you guys can't see a darn thing, but this is coal, nuclear dumps here, other depots, mining, oil and gas development. So this is just zooming in, okay, to one area. Cumulative effects. We need to manage the Arctic for the Arctic. We often look to the rest of the world and say, this is the impacts, these are the effects in the rest of the world. But remember the vortex, we are the world. Okay? Key resources in the Arctic rely on rivers and wetlands. If you link, now I come from a salmon background, so everything revolves around salmon. But if you link all subsistence species, they revolve around water, and mainly around rivers, ponds, lakes. Small changes add up at different rates. So you can change a few things here, and this is actually a very small mining operation near Nome in the background. But the small changes, depending on where they are, what they are, how many of them there are, create these domains of change. And it's very heterogeneous around the Arctic. It's very important to realize that. The Arctic, a system unto itself, these changes in various places, not uniform, heterogeneous mosaic of feedbacks. Okay? Rivers. So this is what's so neat about the Arctic, is this is basically the discharge by drainage basin. These are all rivers that flow into the Arctic. Now, we're flying over the Arctic really high, and we're going to zoom in and look at Alaska. Okay, so we're looking at just this little part here. We're going to zoom in. Here are river basins, okay, major river basins. So you see we're starting, I want you guys to now get these scale differences. We're going to zoom in on this area here, which is where we work. And you guys say, well, there's no river there. And this is a stream network for that little area. Do you guys start to see the scaling here? It's very cool. It's very important. Okay? Now, I'm going to say, let's zoom in on a little area here. Okay, well, there's some big streams there. And this is what we see. Okay, this is actually a map showing permafrost. The grays are continuous and discontinuous. And then the little tiny developments, mines upstream. Okay, so this is showing how many mines are upriver, the density, and then the water sources downstream. And this is a tool that starts to allow us to look at change. So in response to trying to understand how we adapt to change and really trying to step up to the plate and not add to rhetoric, we have developed, in collaboration with the Water and Environmental Research Center, International Arctic Research Center, and some other colleagues, ARVI. ARVI is the Arctic Water Resources Vulnerability Index, and it is not ideas or concepts. It is a precise tool to assess the status of water resources. And it works at the watershed scale because we live at the watershed scale. It unifies Western and traditional knowledge systems because you can't use one and not the other. The two together create a strength. And it can be used by communities so that it's adaptation from the community level, by domains, not top-down. We know top-down adaptation doesn't work. And one has never been developed for the Arctic. ARVI has multiple levels of assessment. You can go in and do a rapid and say, well, there's a red flag over there. Let's look at this area more closely. Do a secondary, and you can really get into it. Okay, when I say this unifies Western and traditional knowledge systems, it uses a lot of what's coming out. It's a really fancy name called cyber infrastructure. It's the fact that information is available in this ether of the web. So in some of the analyses, communities can go onto the web and use these resources. It is Arctic specific, and it basically revolves around the fact that industry happens. It's important that stepping up to this reality and protecting the core values. So we identify the core values in our community, and we say, okay, we're going to protect these core values. And it's unique in that it doesn't just include how many mines are upstream, what the river looks like, geomorphology. It includes social, cultural, institutional, and economic components, and it allows communities to adapt on their own terms. Importantly, it allows communities to adapt at the scales in which they live. Okay, what do I want you to take home? Well, it's a lot of information. Let's start from the beginning. The rate of human consumption is the driver of change. Remember that big picture? Okay, land use change, greenhouse gases, the two climate ecosystem changes interacting together. So greenhouse gases are not the driver of change, we are. Climate change is not a thing, but the consequence of complex feedbacks. I asked somebody what they thought the problem with the world was, and they said, well, global warming. Okay? A diversity of options includes development of resources. Small things add up, and ARVI is a new practical tool for adaptation to change in the north. And you guys should be proud because ARVI is going to have originated from the University of Alaska in Alaska. And I want to thank the wonderful people I work with here, especially Dan who's here and is Bob here, okay, and folks at IARC. Thanks so much, you guys. Oh, questions? Questions?
Were there any questions out there tonight? If you just raise your hand, I'll try to get a microphone over to you. Okay.
Thank you for your talk. I think it's really interesting. My name's Pam Miller, and the focus of this talk has been on adaptation, and I think it also is important to put into the equation what scientists often call mitigation, or reducing and avoiding effects. And this week, the IPCC, an international body of thousands of scientists, has said that the human contribution to global warming and climate change is very likely, which they consider 90% chance. And we can work to avoid the contribution of greenhouse gases, which is contributing to this problem. And I think it's a different realm of the equation than been discussed tonight. But personally, I want to see polar bears when I'm 90 years old existing on the Earth. So my question is, how do you reconcile that kind of both local and national and global mitigation type effort of climate change to your questions?
That's a very good question. I'm going to keep it short and we can talk afterward, but you're not going to like the answer. Small things add up. The energy being used right now, I flew up here. I probably can't say squat, to be honest. I flew up here. I put hundreds of pounds of CO2. Flying from Seattle to DC puts out a ton of carbon dioxide. Let me address it in a general way by saying that small things add up. So for example, if a community changes and another community changes and, for example, decide that maybe we won't live here in winter, or maybe as many people won't live here in winter and we come back in summer, those local changes will add up and they will scale up to the national and global levels. We can talk afterward, but really the answer is by scaling, by basically local changes, changes that you make in your personal life, that I make in my personal life, and then having other people make those changes. So then those all add up.
Any other questions?
I was just wondering, you mentioned agriculture and things going north. If you had any direct information on the growing seasons throughout Canada in the north. I know last summer was rather short with our freeze in June, but hopefully we'll see some improvement.
That is a really interesting and good question. I actually do have a slide for this. It's very cool. The growing season, let me see if I can find the growing season. Here we go. These are the projected changes in growing season. What we're going to see is more changes in really discrete parts. So for example, you may be working in the Yukon growing potatoes or fry in the Yukon, and it may be a better growing season than even just across in interior Alaska. So it's one of the problems is it's going to be highly variable, but right now we're looking at growing seasons increasing by up to 30, 40 days. So this is, there's some really neat, if I get your email afterward, I can give you some data or some information on this. Yeah, a key here is going to be changes in precipitation. We're expecting a little more precipitation, but the growing days are going to be a combination of, as you know, soils, how much rain you get, whether it's too dry, how cold it gets at night. So I don't know, we're expecting an increase. Tell you what, there are a lot of data on that. There are a lot of people working toward sustainability. To be honest, I think that we are going to go through what I call the transition bottleneck. It's basically where we're going to hit the wall. There are going to be people who during the transition, if we don't do it strategically, for example, if we don't start looking at providing jobs, for example, from alternative energy production, and we just hit that wall, there will be people out of jobs. If we start thinking about structuring economies so that jobs go to alternate sectors, to go to diversification of options, then that transition bottleneck is going to be less severe. There is a middle ground, but to be honest, I don't think it is at the current rate of lifestyle we have now.
Good. Anything else? All right, thank you.